Yes, a neutral connection is required for a 240/120 volt rated panel, even when it's connected to a 208Y/120 volt three-phase system and feeds only 208 volt loads. This requirement stems from several factors related to electrical safety, code compliance, and potential future modifications to the electrical system. The National Electrical Code, or NEC, serves as the foundation for safe electrical installations. The NEC outlines specific requirements for neutral connections in electrical panels. Even if the immediate load is exclusively 208 volts, the panel's rating indicates it's designed to handle 120 volt loads as well. Therefore, the presence of a neutral is essential for safety and future adaptability. Firstly, consider voltage stabilization. A neutral connection helps stabilize the voltage within the panel. In a 208Y/120 volt system, the Y configuration implies that each phase is 120 volts to neutral and 208 volts between phases. While the current load might only utilize the 208 volt phase-to-phase connections, voltage imbalances or fluctuations in the system can create voltage differences that could potentially affect equipment connected to the panel. The neutral provides a return path for any unbalanced current, preventing voltage fluctuations and ensuring that the voltage remains within acceptable limits. Secondly, there is the aspect of fault current path. The neutral provides a low impedance path for fault current to return to the source. In the event of a ground fault within the equipment connected to the panel, the fault current needs a reliable path to flow back to the source in order to trip the overcurrent protective device such as a circuit breaker or fuse. Without a neutral connection, the fault current path might be less effective, which could delay the tripping of the overcurrent device and increase the risk of electrical shock or fire. Thirdly, future load considerations are important. Even if the current load is exclusively 208 volts, it's important to consider potential future modifications to the electrical system. The panel is rated for 240/120 volts, meaning it's designed to handle both 240 volt and 120 volt loads. If, in the future, 120 volt loads are added to the panel, the neutral connection will be necessary to provide a return path for the current. Without a neutral, it would not be possible to connect 120 volt loads to the panel. Fourthly, the NEC mandates a neutral connection for most electrical panels, regardless of the specific load being served. The NEC provides detailed guidelines for grounding and bonding electrical systems, and these guidelines typically require a neutral connection for panels that are rated for both 240 volts and 120 volts. This requirement is intended to ensure safety and prevent electrical hazards. Fifthly, equipment protection is an important consideration. A neutral connection helps protect electrical equipment from damage caused by voltage surges or imbalances. Voltage surges can occur due to various factors, such as lightning strikes or switching operations on the power grid. These surges can damage sensitive electronic equipment connected to the panel. The neutral provides a path for the surge current to flow back to the source, reducing the voltage stress on the equipment and preventing damage. Sixthly, harmonic mitigation is an important consideration. A neutral connection helps mitigate harmonic currents in the electrical system. Harmonic currents are generated by nonlinear loads such as electronic devices and fluorescent lighting. These currents can cause various problems, including overheating of transformers and conductors, as well as interference with electronic equipment. The neutral provides a path for the harmonic currents to flow back to the source, reducing their impact on the electrical system. Seventhly, compliance with local codes and regulations is vital. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. These codes may have specific requirements for neutral connections in electrical panels. It's important to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Eighthly, proper grounding and bonding practices need to be maintained. The neutral connection is an integral part of the grounding and bonding system. Grounding and bonding are essential for ensuring electrical safety and preventing electrical shock hazards. The grounding system provides a low impedance path for fault current to return to the source, while the bonding system connects all metallic parts of the electrical system together to create an equipotential plane. Ninthly, consider the function of the neutral. The neutral conductor serves as the return path for current in a single-phase circuit or the balanced return path in a three-phase Y-connected system. It is generally bonded to ground at the service entrance, which creates a reference point for voltage and provides a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protection devices like circuit breakers. Tenthly, code requirements for neutral sizing must be met. The NEC specifies requirements for the minimum size of the neutral conductor based on the calculated neutral load. In some cases, the neutral conductor may need to be larger than the phase conductors to accommodate nonlinear loads that generate harmonic currents. 11thly, the NEC Article 250.24 C outlines specific rules regarding the grounding of the neutral conductor. It emphasizes the importance of grounding the neutral at the service entrance or transformer and provides guidance on the proper methods for establishing a grounding electrode system. 12thly, a missing or improperly connected neutral can create a floating ground situation where the voltage potential of the grounding system is not properly referenced to the source. This can lead to unpredictable voltage fluctuations and increase the risk of electric shock. 13thly, it's important to differentiate between a true neutral and a derived neutral. A true neutral is directly connected to the neutral point of the power source, such as the center tap of a transformer winding in a single-phase system or the neutral point of a Y-connected transformer in a three-phase system. A derived neutral, on the other hand, is created artificially using a zigzag transformer or other means. 14thly, the NEC defines the term separately derived system in Article 100, and it outlines specific requirements for grounding and bonding separately derived systems. A separately derived system is an electrical power source, such as a generator or transformer, that is not directly connected to the primary power source. 15thly, understanding the impedance of the neutral conductor is important for ensuring proper operation of the electrical system. The neutral conductor should have a low impedance to provide a reliable path for fault current to return to the source. A high impedance neutral can impede the flow of fault current and delay the tripping of overcurrent protection devices. 16thly, the NEC requires that the neutral conductor be identified by a white or grey color. This helps to distinguish the neutral conductor from the phase conductors and the grounding conductor. 17thly, the neutral conductor should be installed in the same raceway or cable as the phase conductors. This helps to minimize the impedance of the circuit and ensure proper operation of the overcurrent protection devices. 18thly, the NEC permits the use of a common neutral conductor for multiple circuits under certain conditions. However, there are specific requirements that must be met to ensure safety and prevent overloading of the neutral conductor. 19thly, it's important to avoid creating a neutral to ground bond at the subpanel. The neutral should only be bonded to ground at the service entrance or transformer. Creating a neutral to ground bond at the subpanel can create a parallel path for neutral current, which can lead to circulating currents and other problems. 20thly, the NEC requires that the grounding electrode conductor be sized according to Table 250.66. The grounding electrode conductor connects the grounding system to the earth and provides a path for fault current to return to the source. 21st, surge protective devices, or SPDs, are often connected to the neutral conductor to protect electrical equipment from voltage surges. SPD diverts surge current to ground, reducing the voltage stress on the equipment. 22nd, the NEC provides guidance on the proper methods for installing and connecting SPD. SPD should be installed in accordance with the manufacturer's instructions and should be properly grounded. 23rd, it is important to consider the potential for neutral current to flow on the grounding conductor. This can occur if there is a neutral to ground fault or if there are unbalanced loads on the system. 24th, the NEC requires that the grounding conductor be sized to carry the maximum potential neutral current. This helps to prevent overheating of the grounding conductor and ensure electrical safety. 25th, the NEC provides guidance on the proper methods for terminating the neutral conductor at the panel board. The neutral conductor should be securely connected to the neutral busbar and should be properly identified. 26. It's important to avoid over-tightening the neutral connections, as this can damage the conductor and create a high-resistance connection. 27th. The NEC requires that all electrical connections be made in a workmanlike manner. This means that the connections should be clean, tight, and secure. 28th. It's important to use the proper tools and equipment when making electrical connections. This will help to ensure that the connections are made correctly and safely. 29th. Consider the importance of regular inspections. Regular inspections of the electrical system can help to identify potential problems before they become serious. Inspections should be performed by a qualified electrician. 30th. During an inspection, the electrician will check the neutral connections to ensure that they are tight and secure. The electrician will also check the grounding system to ensure that it is properly installed and maintained. 31st. The electrician may use a multimeter to measure the voltage and current in the neutral conductor. This can help to identify potential problems with the neutral connection or the grounding system. 32nd. If any problems are found during the inspection, they should be corrected immediately. This will help to ensure the safety and reliability of the electrical system. 33rd. In conclusion, even if a 240/120 volt panel is connected to a 208Y/120 volt system and only feeds 208 volt loads, a neutral connection is required due to voltage stabilization, fault current path considerations, future load requirements, NEC mandates, equipment protection, harmonic mitigation, local codes and regulations, grounding and bonding practices, neutral function, and neutral sizing. Proper installation and maintenance of the neutral connection are essential for ensuring electrical safety and preventing electrical hazards.